Hey everyone, welcome to another video in this series. Today, we'll discuss how to utilize encoders in the First Tech Challenge, or FTC. So far, we have been controlling the distance the robot travels with elapsed time. A more accurate way to control movement is with encoders. Encoders are sensors that can attach to or are integrated into the drive motors and provide feedback on the rotation of a motor or the position of the mechanism. They can be used in autonomous or teleop programming to accurately control the movement of a robot. By utilizing encoders, you can measure the distance traveled of a robot or the precise position of specific components. Here's how you can use encoders in autonomous programming for FTC. To set up the hardware, connect the encoders to the port attached to the motor port, connecting the motor to the encoder it's measuring. If the encoder is external from the motor, attach it to the motor axle. In order to program these encoders, declare the motors and set their directions as you normally would. Set the power of the motors to 0.5 for now. You can change this value later. Now, you have access to functions such as get motor position, which can tell you the number of ticks the encoder is currently at. In order to use it, at the beginning before the robot moves, you want to write the line motor.setMode, dcmotor.runMode.stop and reset encoder for each of your 4 drive motors. This ensures that your encoder is always set to 0 when you first start the program. Next, for each of your encoded motors, add the line motor.setMode, dcmotor.runMode.run using encoder. This will ensure the motors are, using the encoders. In order to get the robot to move, set a target encoder position for each motor, using 4 variables such as left front target position, right front target position, etc. Initially, you want to set all these values to 0, and then add on to it or subtract. For example, if you wanted the robot to drive forward, you could add 2,000 ticks to each of these variables. Then, add the line motor.setMode, dcmotor.runMode, run to position for each of your motors. Once ran, this should make the robot move forward. After that, you can change the variables again and have them run to their position to make the robot move again. As a tip, increasing all of the encoder variables should make it drive forward, and decreasing all of them will make it go backward. Increasing the right wheels and decreasing the left wheels will make it turn left, and increasing the left wheels and decreasing the right wheels will make it turn right. To strafe left, your variables for the front left and back right motors should decrease, and your variables for the front right and back left rear variables should increase. Once you have finished all of the movement code, set the power of the motors to 0 to get the robot to stop. Remember, to test and fine-tune your autonomous programming, consider factors such as wheel slippage, weight distribution, and environmental conditions to ensure accurate and reliable performance. If you enjoyed this video, please consider showing your support by liking the video and subscribing to the channel. That's it for now. Thank you so much for watching.